Today, I want to talk about how Facebook and Instagram, which are both owned by Facebook, use artificial intelligence to keep you coming back, right? Keep the basicness rolling alive. And you might be saying, like, Kevin, you're coding. Like, why are you wearing a suit? Because, like, I'd be looking good for my IG debut. This is what you guys see each and every day, right? Like, you see some form of attractive persons here, even though this is a travel category. It looks like there's one travel here. Good looking dude here with a dog. That's always a winner, right? And then obviously cute cats. And then America, right? With some eagle freedom, right? Like, how do they know what to send you? Right here, it's from Volpal Wabbit, which sounds like I'm not saying the word rabbit correctly, but it's actually a Lewis and Carroll, like, nonsense word that the guy designed the package after. Anyways, you get the idea. The main thing we're going to be doing is contextual bandits today. So if you watch my other Netflix video, you'll know that I designed a multi-arm bandit. Well, this is going to be a contextual multi-arm bandit. Well, what's like the difference? The only difference is I'm going to add features. So rather than me just recommending movies, I'm going to be like, okay, Kevin likes this, or someone likes this type of stuff based on their age, their demographics, right? Like all these different things. So all I'm going to do is just add context, and that's going to make the algorithm a little bit more complex, and it's going to inch closer to reinforcement learning, full on reinforcement learning, but it's going to be a little bit different. Anyways, the context is going to be the user and the time of the day. So I decided to name my two users Chad and Karen, and they have actions of articles that we're going to send them each day. Attractive people, basic clout items, and workout stuff. Attractive people, pretty self-explanatory. That's pretty much all I see on any of my friends' Instagrams, is like just attractive people. And then basic clout items. So we're talking like your Starbucks, your Lululemon, your Target, the workout stuff, right? Like fit people, protein, all that fun stuff that I need, right? I'm going to simulate the reward. And in Volpal Rabbit, the thing you have to do is you have to minimize the cost function. You're not maximizing reward. So instead of it being like a 1 for a good article, I'm going to say it's a -1, because remember, I'm trying to minimize a negative, or I'm trying to make it as negative as possible. Think like golf, right? That's just the way that this algorithm works. And then I'm going to have the cost function. This is just like a helper function, like Chad in the morning and attractive people, he likes it. And if he's in the afternoon and it's workout, and he likes workout stuff, and then he likes it, right? But Karen in the morning, she likes basic stuff, and then she likes attractive people in the afternoon, right? And so this is, again, helper function just to fit into Volpal. And you can see, like, here's a printout of what it looks like user, Chad, time of day, morning. And I have 3 actions to pick from, right? Show him an article of attractive people, basic items, or workout stuff. Like, what does Chad like? And that's what our algorithm's going to figure out, is like what to send him at what time of the day. Moment, right, that we send Chad something, we're going to get some probability that he'll click on it and like it, right? So, like, let's say this is attractive people, and this is workout stuff, and this is basic clout items, right? So, like, every single time we pull an arm, we're going to have some bar chart, right? Think of it as some bar chart of different items that we could send to him, right? So this is like a 50% chance, and this is a 20% chance, and this is a 30% chance that he'll interact with this article, right? And as we simulate this environment, these bars will change up and down until eventually it will converge to what we know to be true, right? We know Chad, right? Maybe this, again, let's say this is like the workout stuff in the morning, and it's a third, maybe it's going to be like 85% of the time we know we should only send Chad workout stuff in the morning, and then every once in a while we should send maybe like 6% of the time for the other 2 guys, like just to make sure that he doesn't want to look at basic stuff or attractive people in the morning. And so our algorithm over the long term is going to converge from not really knowing stuff, and as Chad clicks and interacts, it's going to update his profile, right? And then we're going to know as an algorithm, like, what are we more likely to send Chad as we move forward in time? And this is how the algorithm gets smart about what it knows you want to click on, and it gets smarter and smarter about you as time goes on. It's an action, like get an action, right? Like I'm just going to grab an action. Again, just helper functions, no big deal. And here's kind of like a preview. I wanted you guys to see like what like the ultimate dynamic that we're shooting for is. We know that Chad is going to get a -1. Remember, that's like positive in this example. If we show him workout stuff in the afternoon, and we're going to show him attractive people in the morning, and we're going to show Karen attractive people in the morning, but we're going to show her basic clout items in the morning. Sorry, in the morning. And so these are kind of like the arms. These are like the objectives, like that we want our algorithm to learn. Like, for sure, if we show it at this time, that's what this person is going to click on, and they will come back to us. And so this is how your feed changes throughout time. And you'll notice, like, if you're looking in your Instagram feed, you'll probably have most of the stuff you care about, but every once in a while there'll be like a couple things that like don't seem to make as much sense with like the rest of the layout. That's them testing other arms. That's them saying, like, you know what, maybe he likes mountain biking a little bit, right? And they throw in a mountain biking picture, and it's like, I click on that, and the algorithm goes, hey, he does like mountain biking. He clicked on it, right? Maybe we'll show him a couple more of those as time goes on. So every day we're going to run a simulation. We're going to decide between Chad and Karen, right? Every time I run the simulation, I'm going to pull Chad or Karen, the time of the day. I'm going to pass the context, right? So both of them, user and time of day. I'm going to receive a reward. I'm going to format it in the Volpau Rabbit, and I'm going to see if it learns throughout time, like which arm is the best to pull at which time of the day for which individual. So if I start running the simulation, right? Simulation, here's a user, time of day, context. I just put them together, and then get the cost function, like get me the reward, yes or no. And then if I want it to learn or not. And so I'm going to show you two things. A lot of websites won't do like some learning-based algorithm, and I'll show you the results of like a learning-based algorithm and just kind of like a random-based algorithm, and you'll see why AI makes sense to use in these contexts and like many places in life. Scenario 1, I want to do it with a learning function. So here I'm just instantiating Volpau Rabbit. Epsilon is 0.2, so just 20% of the time explore a new arm, but mostly pull the arms that I care about. And then here we go. I'm going to pull out a couple of instances so that you can see what the algorithm was doing and how it started learning. So in the very beginning, you can see that I had Chad, and the time of day was afternoon, and the algorithm picked attractive people, and it said there was a 33% chance that Chad is going to interact with it. Now, honestly, I don't remember if the afternoon was attractive people for Chad or not, but either way, the algorithm is only 33% confident that we're going to actually pull this arm and get a reward back. But print like the very beginning reward, and I had this guy print like the 1,000th reward, and you can see by the 1,000th reward, if the user is Karen and the time of day is morning, it is 86 and some change % confident that if we show basic clout items to Karen in the morning, we're going to get a reward. She's going to click on it. She's going to stay on Instagram, right? She's going to feed the monster. The algorithm might every once in a while show basic clout items to Chad in the morning, right? So 20% of the time it might show like a mocha fropa frappuccino from Starbucks to Chad. Maybe he clicks on it, maybe he doesn't, right? But the algorithm has to like explore these opportunities to see if it's useful or not. Ultimately, the best part is we can see that the algorithm starts to learn, right? So this is the very beginning, and then as we go through time, it starts to converge to like this 86% confidence that anytime it sends you some article at some time of the day, it's pretty certain you're going to click on it or you're going to interact with it. Now, the one thing you might be wondering is right here in the beginning, this is the same with like the Netflix MAB, is right here in the beginning, it doesn't really know much, right? And as the saying goes, like if you're not paying for the product, Instagram, Facebook, you are the product. It is learning from you every time you click on something. So in the beginning, it really doesn't know like what to send you or when. And eventually, right, you'll see like a bump here and a bump here and like another bump here, right? It's testing what it should send you. And over the long term, it really designs a profile as like who you are as a person, and it knows what to send you, what actions you have taken, such that over the long term, it'll maximize you to come back to the platform. If you come to out learning, so notice same exact setup, but the algorithm, every time it selects something, is only 33% confident. Like even as I go through the 1,000, 2,000, 3,000th iteration, it's not very confident about what's going on. This is what used to happen before AI really got into like advertising, is they would just randomly smatter different things. Does he like that? Does he kind of not like that? And then through time, they would try to like manually be like, all right, if he's a young male and he's 28 and it's the morning and we know he's single, right? He's going to look at attractive females first, right? And then they would try to hard code that, right? And there was all these decision rules, but there wasn't something that intuitively was learning throughout time. If you enjoyed it, please like, rate, subscribe, And check out the other videos if you want to learn like how Netflix does recommendations, or like how you can optimize like sanitizer bottle placement to reduce COVID and other things like that. Anyways, guys, I appreciate it. Have a great day. Thanks.